All right, so we've talked about exponent rules when we've got multiplication involved, and we've talked about exponent rules when we've got quotients involved. Now we're going to look at a couple of other rules, what happens when we have a zero exponent, and also what happens when we have negative exponents. And what I want to do is I want to just make kind of a table for you. And let's say I took the number 2, and I raised 2 to the third power. What is 2 to the third power equal to? Well, that's equal to 8, right? 2 times 2 times 2 would be equal to 8. If I took 2 to the second power, so I decreased the exponent by 1, what's 2 to the second power? Well, that's equal to 4. And if I took 2 to the first power, again, I decreased the exponent by 1, I get 2 to the first power is equal to 2. Now, what's happening to the answer each time over here? When I decrease the exponent by 1, what is happening each step of the way? Well, we cut that in half, right? We divided that by 2. So when I lost an exponent over here, when I decreased the exponent by 1, I divided the answer by 2. Same thing here. When I decrease the exponent by another one, we divide by 2. So if I continue that pattern and I go from the exponent of 3 down to 2 down to 1, if that pattern is going to continue, what would 2 to the 0 power equal? Well, if I took 2 and divided it by 2, I would get 1. Okay, this pattern, 2 divided by 2, 2 divided by 2 is equal to 1. And what would happen if I decrease the exponent again to go from 1 to 0? This would become a negative exponent. Each time I'm decreasing by 1. Well, if I take this answer and I divide it by 2, I get a half. Notice that it doesn't become negative, but I get a fraction out of it. Okay, and that's what happens when we have a zero exponent and we have negative exponents. Okay, so let's go over here and look at our rule. First of all, the negative exponent property. When I have a base raised to a negative exponent, we get a fraction out of that. We get 1 over the base to the positive exponent. So let's look at this example number 1. This says 3 to the negative second power. When I have a negative exponent like that, I'm going to say it equals, I'm going to make a fraction out of it. It's going to go 1 over 3 to the positive second power. Notice when that term, right now, it's 3 to the negative second over 1. When that term drops down to the denominator, that exponent becomes positive. And I would say that's 1 over 9. Okay, so that's one rule. Okay, the other rule is the zero exponent. Look, remember my table up here? 2 to the 0 power turned out to be 1. Okay, any number to the 0 power equals 1. So example 2 over here. This is negative 7 to the 0 power. If the exponent is 0, it's going to equal 1. Doesn't matter what the base is. If it's to the 0 power, it equals 1. Over here, doesn't matter what the base is because it's a 0 power, that equals 1. Oh, wait a minute. I'm a little bit off here. There's no parentheses here, so this is negative 1 times 7 to the 0 power. So this would be a negative 1 times 1. This will be a negative 1. Okay, 2/3 to the 0 power. You could break that up if you wanted to and say that's 2 to the 0 over 3 to the 0. But those are both 1. So that whole thing's going to equal 1. Okay, now we have a fraction to the negative exponent. Okay, this is going to be equal to 1 to the negative second over 5 to the negative second. What happens in a fraction? Well, this is a negative exponent where it is, so we are going to drop it down to the denominator, and then it's going to become positive, a positive exponent. Just like up here, when the 3 was to the negative second exponent, when we dropped it down to the denominator, the 2 became positive. Same thing here. If it's already in the denominator, we're going to move it up to the numerator. So this is going to be 5 to the second. Okay, and I'm going to simplify those. 5 to the second is 25 over 1, or 25. Okay, 0 to the negative third power, 1 over 0 to the positive third. Well, we can't have 0 in the bottom of a fraction. That is undefined. Okay, so we can't do that one. If you did that with your calculator, you get an error message. All right, let's see these bottom examples. I've got a negative exponent. It's already in the denominator, so it's going to pop up to the numerator and become 2 to the positive third over 1. 2 to the third power equals 8. Negative 8 to the negative second. I'm going to say 1 over, it's still a negative 8. The base does not change. It's the exponent that becomes positive. Okay, and if I took a negative 8 and squared it, I would get a positive 64. Okay, this is going to be equal to 4 to the negative third over 5 to the negative third. So we never leave an answer with a negative exponent. That's going to have to drop to the denominator where it's going to now become positive. And this is negative where it's at, so it's got to bump up to the numerator to become positive. This would be 125 over 64. Now, at the bottom of this, we're going to put all of our rules together. So you're going to have the multiplication rules, you're going to have the quotient rules, you're going to have 0 as an exponent, you're going to have negative values as exponents. So we're putting everything that we've learned about exponents together. Okay, this is a product, this is multiplication, so the rule for powers is to add. Base stays the same, I'm going to add those two exponents together. Negative 4 plus 4 is 0. And I never leave 0 as an exponent. 6 to the 0 power equals 1. Okay, this is a power raised to another power, so I'm going to apply my rule. Base stays the same. I multiply my exponents. I get 4 to the negative fourth power. I never leave a negative exponent, so I'm going to say 1 over 4 to the fourth power. 4 to the fourth power, we can do that. 4 times 4 times 4 times 4. We could leave that, or we can say that's 1 over 256. I'd be okay if you left it like that though also. Okay, here's a quotient. Even though we've got a negative exponent in there, we've got a quotient. Okay, so we leave the base stays the same and we subtract our exponents. So negative 1 minus 2, we always subtract from top to bottom. Okay, that's going to be equal to 5. I would do leave, change, change. That's 5 to the negative third. Okay, I do not want to leave a negative exponent in my answer, so I'd say 1 over 5 to the positive third, which is 1 over 125. Okay, we've got a power raised to a power here, so we're going to go ahead and multiply. The base stays the same. When I multiply a negative times a negative, it becomes positive. I don't have to worry about a negative exponent anymore. 5 cubed is 5 times 5 times 5. That's 125. Okay, I'm going to skip down to example 16 here. I have 1 in the numerator. In the denominator, I have 15 x to the 10th y to the negative 8th. Okay, there's nothing that I can do with the x and the y's, but this is a negative exponent. We can't leave an answer with a negative exponent, so I'm going to bump that up to the numerator so that it becomes positive, y to the positive 8th, over, I still leave the 15x to the 10th where it's at. Okay, here I've got to simplify in parentheses. It's a negative exponent right now. All of it's to the negative power, so I can bump it all up to the numerator. Say 9 times, this would become 3d, now would be to the positive third power. And I would have 1. Everything left the denominator and went up to the numerator, so it's over 1. And we would have to simplify that. So it would be 9 times 3 to the third times d to the third over 1. 3 to the third is 27. 27 times 9. That would be 63 and 6, 18. Is that 243, I believe? D to the third. I don't need to put 1 in the denominator. So 243d to the third. And this bottom one's probably the most complicated it gets. I'm going to, for starters, I'm going to leave the numerator where it's at right now. I'll come back to that in a bit. I'm going to square the denominator. So 4 to the second power would be 16. X to the negative second raised to the second would be x to the negative fourth. And then y to the negative sixth raised to the second would be y to the negative 12th. Okay, we've got coefficients here, 12 over 16. That can be reduced. They're both divisible by 4. That's going to become 3 and 4. I can subtract my exponents. This is going to be x to the 8 minus a negative 4. If I did leave, change, 8 minus a negative 4. If I start, you always start in the numerator with that exponent. 8 minus a negative 4 plus a positive. So it's going to be x to the 12th. And down here, you'd have negative 7 minus a negative 12. So I do leave, change, and that's equal to 5. So y to the 5th. Okay, so in the denominator, I just have 4. And in the numerator, I have 3x to the 12th, y to the 5th. So here is an example of how you're going to get practice putting all of your rules together. Okay, and it does take some practice. So give it a shot. Make sure you get your homework done.